So this is a sample lecture, and so what I thought I'd talk about just briefly is the coronavirus. And so really this is just about infection. And so since it's in the news, I thought maybe we could talk about it as a sample lecture. And so I'm just going to give you some numeric examples that we can discuss here to talk about subjects like self-quarantine, social distance or social distancing, and maybe panic, stuff like that. And so as the example, I'm going to say, look, suppose we have a virus. And we're just going to make up some numbers. Emphasize that. This is all made up. So we're going to say, look, a disease has a rate of infection and I'm going to say that's 1%, just to pick a round number. And what that means is 1 in 100 contacts gets infected on average. Right? And so what that means is, if I have a contact with a person, and maybe we'll talk about what we mean by a contact later, but maybe it means you stop and talk to them for a second, or you get inside that 6-foot radius or something like that. But we'll say 1 in every 100 contacts on average transfers infection. So if I'm an infectious person, if I have the disease, then on average 1 out of every 100 people I have contact with, not necessarily touching, but just some interaction inside their zone, they get it. All right, and we'll just assume that average. And so the second thing I'm going to say is, in this example, eye contact, I have it. And I contact 100 people per day. So either, maybe I live in an urban area probably that, or, I'm a classroom teacher and I see 100 students a day and have some interaction with them. Either I'm just walking past them, maybe and getting in their zone, or walking down the hallway, or I stop and have a conversation with them. This is anybody in their job. Maybe you work in the fast food industry, you might see more than that. But anyway, I have about 100 contacts per day. So now I've given you enough information with these two statements for you to determine the rate of growth of the disease, provided you assume that everybody has this infection rate and everybody is contacting about 100 people per day. So take a minute and see if you can figure out what that is. You can pause the video if you need to. I'll erase the board. Right? And so now we're going to say, I'll go ahead and answer that question for you, right? So if the rate of infection is 1%, and I contact 100 people per day, then one person gets the disease each day from me, right? If I contact 100 people and I have a 1% rate of infection, then one person every day gets it. And so if those numbers are the same for everybody, that is to say the people I transfer the disease to also have a 1% infection rate and also contact 100 people a day, we're just picking averages, then after the first day, it's just me and the person I contacted. After the second day, we've each contacted another person, and so it's 4. And then after the third day, it's 8, and after the fourth day, it's 16, and so it goes 2, 4, 8, if you want to put 1 first, 16, 32, 64, 128, 256, 512, and 1,024. Try that again. If this is the day I contact the first person, it's day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And so the rate of growth of this virus is 2 to the n, where n equals the number of days. And you can say after 10 days, 2 to the 10th equals 1,000. Roughly, it's 1,024, but okay, we're just kind of dealing with approximate things. So after 10 days, I've gone from 2 to 1,000, basically. And so we could continue this, and you can if you want on your own. If I go to 20 days, 2 to the 20th is approximately 1 million. Okay, and so I've now in 20 days, assuming everybody has the same level of contagion and the same number of contacts, in 3 weeks I've spread the disease to 1 million people. There's all kinds of things wrong with this. People have different people have different numbers of contacts. People aren't infectious usually for 3 weeks, something less than that. But we're just looking at round numbers here and just trying to understand a little bit about how this works. And so now I can say, suppose I self-quarantine. So let me change that, say we. So suppose we self-quarantine and reduce the number of contacts to 50 from 100. So instead of seeing 100 people a day, we see 50 with the rate of infection is still 1%. Right? And so so in the previous case, it doubled every day, right? That was our rate. Sorry. So now I'm going to ask you, what does this one do, right? And so I'm going to erase the board. You can stop the video and ask yourself, what happens if I have a rate of infection of 1%, I have 50 contacts per day. After 10 days and after 20 days, how many people have been infected, right? And so let's talk about that. So So if the number of contacts is 50 and the rate of infection is 1%, I've got to contact about 100 people before I transmit the disease. And so on average, it's going to take 2 days for me to get a contact. And so, in 10 days, it doubles 5 times, right? Because it doubles every 2 days now. It takes 2 days for me to get 100 contacts, to get 100 contacts. And so in 10 days, it doubles half as many times. So it only doubles 5 times. 2 to the 5th is equal to 32. So after 10 days, instead of having 1,024 contacts, by self-quarantining even just down to 50 people from 100, I've reduced my number of people with the disease from 1,024 to 32. And you can see that in 20 days, it doubles 10 times. 2 to the 10th is again equal to 1,024. We'll just call it 1,000, roughly speaking. And so, so in 20 days, I have 1,000 rather than 1,000,000. And so you can see that self-quarantining is an effective way to reduce it. Furthermore, if the number of contacts is 25, then it takes me 4 days for the disease to double. And so that means in 20 days, so the rate of spread of the disease is dramatically dependent. In 20 days, I have 32 cases. If my number of contacts is 25 per day, I have 1,000,000 if it's 100 per day. And so you see a dramatic difference you get by self-quarantining. And that's why states and municipalities are trying to get people to self-quarantine, because it has a dramatic effect on the rate of spread of the disease. So the other number, we've talked about the number of contacts, right? Let's talk about the rate of infection. So the rate of infection is how often a contact results in a transmission, right? And so let me make a quick comment about social distancing. In addition to self-quarantining, social distancing also reduces the number of contacts, right? Even though I stand and talk to somebody who's 6 feet away, right? If we're far enough away, then the disease can't transmit between us. And so if I'm 6 feet away, I can say this is not a contact. And so social distancing reduces the number of contacts. And so I have lots of different ways of affecting how many people I expose to the disease by both self-quarantining and social distancing, and you've seen the dramatic effect it has on the numbers. So there are other ways I can influence the spread of the disease. And so let me just talk about that for a second. This number, the rate of infection, This is sort of an average. In our example, we used 1%. And this is just sort of an average of what, all of your contacts in the day would result in, maybe. And it would be vary from disease to disease, kind of, and some are more infectious than others. The coronavirus appears to, transfer by in water droplets from spit and things like that, and contact on surfaces. And so this was, I have no idea if this number correlates with the coronavirus. I'm sure it doesn't. I just used it for an easy number to pick. But but we can adjust this number as well. For example, we can clean surfaces before we touch them. So you might go into a grocery store and wipe off the cart, or wash your hands, so that even though you had a contact with somebody or with something that involved the infection, you've eliminated it by killing it before it got into you. And so even for contacts you had, you've taken enough precautions to make sure that somebody sneezes, maybe that gets on your hands. You don't put your hands in your face, or you touch a surface that gives you some exposure, and you wash your hands before you use them. And so you can cut if I cut my rate of infection to 0.5%, say, then I have to contact 200 people to get one person infected. In order to multiply 0.5% to get 100% on one person, I have to see 200 people on average. And so if my contacts were 100 a day, then it would double every 2 days. It would be back to that 1% contact, the same numbers for 1% rate of infection, contacting 50 people a day. And so anything you can do to this number, the transference of the disease to other people, to reduce it, maybe wearing a mask, maybe wearing gloves if you're infected, just staying home if you're infected, of course, are other ways to reduce the rate at which the disease spreads. Okay, the last thing I wanted to talk about was panic. There's a nice article in an engineering magazine about whether or not we're panicking. You kind of see people are saying, well, you're acting out of fear, or you're panicking. So mostly people say panic is when most people say panic is when your reaction is inconsistent with your risk. If I'm a healthy person, I'm most likely I'm just going to get a headache and maybe a fever and some nausea associated with this disease. And so why should I bother? The odds of it actually having an impact on me are small. And so I shouldn't, if I'm sequestering myself, if I'm self-quarantining, if I'm getting wipes and wiping down, if I'm not communicating with people and seeing people, my reaction is inconsistent with the level of risk I'm at. The reason that isn't a very good criticism is because you have to look at the whole picture. If I have a large population, then as you can see from the growth rates on the previous pages, there's a very rapid growth rate if we allow the disease to spread. And so my behavior affects the chances of somebody who's in a risky position to get infected. And so if I take risks, that are safe for me, that because I'm a healthy person, or because I eat right and exercise or whatever, depending on who you are, if you don't feel like this affects you, you're probably right, but you're wrong in assuming that your behavior won't affect the chances of somebody else surviving. If you're one of the people who's transmitting the disease sort of exponentially, the disease is going to find its way much more easily to people who are vulnerable, and those are the ones we're trying to protect with this. And so if you're only looking at your personal risk, you can say, yeah, it's panic. But extreme actions are required if you want to save the people who are in the most danger.